Welcome back to my YouTube channel. Today we are going to discuss about arrays. Understanding arrays. Arrays are fundamental data structures in programming. They are the building blocks for handling collection of data effectively. The presentation will guide you through the core concept from definition, declaration, and advanced processing techniques and real-world consideration. What is an array? A fundamental data structure. The computer science. In the computer science, an array is a collection of items stored at a contiguous memory locations. The idea is to store multiple items of the same data type together. This makes it easier to calculate the position of each element by simply adding on offset to a base value, which is a memory address of the first element. Key characteristics. Stores elements of the same data type. Example, all integers or all strings. Elements are accessed using an index. Fixed size. Once declared, the size of the conventional arrays are usually cannot change. Contiguous memory locations ensures fast accessing. And the next part is declaration of arrays. How to reserve memory for collections. Declaration is a process where you inform the compiler about the type and the size of the array. This reserves the necessary contiguous memory space. The exact syntax varies among the programming language. In C language, it is taken as data type name in the square brackets the range of the size of the array is declared. This is how we declare the array. Types of array specifications. You must specify the data type of the elements and the number of elements the array will hold. For example, in C language we might declare array of 10 integers. The syntax. Most traditional arrays use static memory allocations, meaning the size is fixed at a compile time. Some languages or library implications offer dynamic arrays that can resize, but the understanding data structures management is more complex. Initialization of arrays. Initialization is the process of assigning values to the array elements after declaration. This can be done immediately upon declaration or element by element later on in the program execution. Immediate initialization. String name in the string name square brackets equal to curly braces. We can define the number of elements, or else element by element assignment. Assign values using index operator, which is square brackets in a loop sequentially. This is common when data type is read from the user input or a file. Data and the index is written in the square brackets equal to 50. That means in the 0th position the value 50 is stored, and in the first position the value 65 is stored. Default initialization. If the values are not exactly provided, elements are often initialized to a default value. Int scores 5. That means we are assuming that we are first taking 5 integer values, which is called as index, and the 0th value, the index of the array starts from 0 to n-1. So the 0th value, the array which has 0 as index stores the value 0. This shows in the example. The next one is accessing array elements, retrieving data with indices. The zero-based index system. The most modern programming language like C, C++, Java and Python, arrays are zero indexed. This means the first elements in the index is 0 and the second element in the index is 1. This is what we discussed in the above example. Attempting to access elements using the index outside the valid range results in an index out of bounds error, which can cause a program crashes or unexpected behavior. The next one is processing arrays, common operation and loops. Their common operations like processing arrays involves applying operations to the elements, typically using iteration structures like loops. These operations are essential for tasks like searching, sorting, and aggregating data. Searching. Find a specific element index or a presence is called as searching. Sorting. Arranging the elements in a specific order is called as sorting. Aggregating. Calculating statistics such as sum, average, maximum, minimum value of elements is called as aggregation. Iteration. The for loop is the most common construction of the transfers and manipulate every element in an array systematically. Type of arrays. There are majorly 1D arrays, 2D arrays, and a multidimensional arrays. 1D arrays use sequence of elements indexed by a single position. 2D arrays. There are rows and columns layouts accessed by rows and columns indices. Single dimensional arrays. The simplest form, often visualized as a single row or a list of elements, requires one index. Used for storing list of names, scores, and linear data sequence. Example, int array 10 semicolon. Multidimensional arrays, which are two-dimensional arrays or beyond two-dimensional arrays, which may be 3D, 4D, or 5D. Array of arrays, often used to represent matrices, tables, or grids, requires multiple indices to access an element, commonly used for image processing, game board, and tabular data. The next one is like advantages of using arrays. Arrays offer several significant advantages that make the preferred data structure for numerous applications, especially when dealing with a known or a fixed amount of homogeneous data, which are fast access. Random access to an element is extremely fast due to contiguous memory allocations and direct address calculation using the index. Memory efficiency. They do not require extra memory overhead for the pointers or link between elements, maximizing the space utilization. And next one are like cache locality and foundation of structures. Disadvantages and limitations. Despite their benefits, arrays have inherent like some limitations, primarily due to their fixed size, nature, and complexities involved in the insertion and deletion operation, which are fixed size. The size must be specified at the time of a declaration. If the number of elements exceed the array capacity, it leads to the overflow and error is shown on the screen. Costly insertion or deletion. Insertion or deletion of an element in the middle requires shifting all subsequent elements to maintain contiguity, which means continuity, resulting in O on time complexity. Homogeneous data types. That means we cannot store different types of data types in a single variable.